Welcome to Animated Maths for All Series 2. This video focuses on learning, growing, and excelling in mathematics. At Animath International School, the water tank is cleaned every few months. The water is collected and repurposed. Students observe that it takes 30 minutes for the cylindrical tank to empty completely, partially filling the cuboidal tank below. We are given that the cylindrical tank capacity is 5,000 liters, and its water fills 2/3 of the cuboidal tank, which has a base area of 12,000 square centimeters. Our goal is to find the height of the cuboidal tank and the rate of water flow in cubic centimeters per second. Let's begin by determining the volume of water transferred from the cylindrical tank to the cuboidal tank. First, we convert the volume of water into a common unit of measurement. Since 1 liter equals 1,000 cubic centimeters, the volume of 5,000 liters is 5 million cubic centimeters. We use cubic centimeters to match the base area units. Next, we will use this converted volume to determine the total capacity of the cuboidal tank. Step 1 is volume conversion. The 5,000 liters from the cylindrical tank is the volume of water transferred. We convert this to 5 million cubic centimeters. Now let's find the total capacity of the cuboidal tank. We use the relationship between the transferred volume and the fraction of the tank filled. The 5 million cubic centimeters of water fill 2/3 of the tank. To find the total capacity, we calculate 3/2 times 5 million, which is 7,500,000 cubic centimeters. With the total capacity determined, we can proceed to find the height of the tank. We will use the volume formula. Volume equals base area times height. We apply this to solve for h, the missing height variable. We are now ready to perform the final calculation for the height. The volume of the tank is base area multiplied by height. So 7,500,000 equals 12,000 times h. Now we need to find the height of the tank, h. Let's take a brief moment to visualize the relationship between volume, base area, and height. To find the height of the tank h, we divide 7,500,000 by 12,000. This simplifies to 7,500 divided by 12, which equals 625 centimeters. The height of the cuboidal tank h is 625 centimeters, or 6.25 meters. The next step is to find the rate of flow of water in cubic centimeters per second. We need to convert the time in minutes to seconds. The total time taken for the cylindrical tank to empty is 30 minutes. To convert the minutes to seconds, multiply the number of minutes by 60. Therefore, 30 multiplied by 60 equals 1,800 seconds. Now, we can find the rate of flow of water per second. We will use the total volume of water transferred and the total time taken in seconds. To find the rate of flow of water in cubic centimeters per second, divide the 5 million cubic centimeters by 1,800 seconds. This calculation will give us the rate of flow of water. First, cancel the 2 zeros in 5 million divided by 1,800. Which results in 50,000 divided by 18. Dividing both numerator and denominator by 2 gives 25,000 divided by 9. Dividing 25,000 by 9 yields approximately 2,777.77. So the rate of flow of water was 2,777.77 cubic centimeters per second. Think about this and verify your answer in one of the forthcoming sessions, 9. This video demonstrated how to find the height of a tank and the rate of flow of water by applying volume and rate concepts. Thank you for watching Animated Maths for All series.